Okay, thanks for everyone for showing up. You want to go ahead and start out? Steve has a short presentation, and then we'll get to Joe's.
I'll start by saying I did this at the ASEM general meeting, and since so often there's the one I want to share. So often the crowd's different here versus there. We thought it'd be a good idea to do again. So slideshow, start from the first slide. Every once in a while, the Astronomical League comes up with what they call an observing challenge. And they have this month announced a brand new one, and it's called Galaxy Season. And the idea is you're going to make some observations or images of galaxies. If anybody is ever interested in seeing this short presentation here, you can go to that tinyurl.com Galaxy Challenge, and it'll load this guy up. So anyway, it says it right there. Every so often, they come up with great ideas, usually not the solar system stuff. If it's something in the solar system, they'll usually couple that together with the NASA and have what they call a NASA Astronomical League Challenge, but these are just Astronomical League things. And in the past, two that you may have heard of, one of them was the Great Conjunction, which was like December of a year plus ago. And that was when Saturn and Jupiter were together, and we kind of imaged those. And another example was one that was actually going on last summer, and that was called the 25th year anniversary. And in the 25th year anniversary, that turns out to be something where you would image like Jupiter 75 times. And imaging Jupiter 75 times is a whole lot of work. So ultimately, I think only about 3 people did that Jupiter challenge. So anyway, now there's a new challenge. And like I said, it's called Galaxy Season. To work on this program, what you have to do is an outreach activity that's related to the challenge. The challenge is about galaxies. So somehow as you do outreach, you would need to mention galaxies and talk a little bit about galaxies. I got some ideas on that a little bit later here. Ultimately, you're going to need to turn in some information to the Astronomical League about the observations. You know, the number, by the number, they mean like there are 22 of them you pick. I'm going to do number 4 number. And then, you know, what the name of the object is. Ultimately, the time of the day, you can use UT or local, or I guess if it passes really soon, you might just be able to say, you know, hey, daylight savings time forever. Ultimately, you need to report the seeing and transparency. Ultimately, if we're imagers, seeing and transparency is not all that important. You could probably get by without doing that. You need to say where your images have been taken. You know, latitude, longitude wise, what the what the instrument is, if you're doing it visually, what the eyepiece was, and the magnification. If we're imaging it, you need to report, you know, whatever cameras you're using, any particular focal length modifiers, probably any kind of filters. They say brief description. I don't know if we need to do a description or not for imaging, but you know, I can check with that. And then lastly, if you're doing it visually, you need to make a sketch. If we're an imager, well, gee, I guess you need to make an image. I hit the space bar and nothing happened. There we go. There are 22 targets as part of the program, okay? You don't have to do all 22. The magic number turns out to be 12, and you would pick 12 and image them. Depending upon the field of view you pick, you may be able to get multiple ones in the same field of view. If you got somewhat of a wide field setup, you're going to be able to get M81 and M82, okay? The Whirlpool's got a couple. You know, down here, they talk about the antenna galaxies. There are going to be a couple you're going to be able to see. The eyes are going to be a couple to see. I see Leo triplet in here twice. So there's a case where you're going to get some there too. I'm thinking when it says Leo triplet, in this one image, you're probably going to want to do M65. And in the other one, you want to make sure you see M66. But those are the targets that you would take, okay? And when it comes time to submit, when you think you're done, you send along your 12 observations, your 12 images, or at least your 12 targets, and you need to include your name, your address, and all those things down the page. I think it's funny because ultimately we're going to get, I talk about it on the next screen, a certificate, and the certificate is an electronic certificate, probably going to be a PDF that's emailed to you. And so I'm not sure why they want to know your address or your phone number, but oh well, they asked for it, so I put it there on the slide. If for some reason you don't want it to go to you, if you'd want it to go to somebody in the club, else, in other words, you say, oh, send it to Dan. Dan's got a really good printer, you know, that you would have his address that way. Ultimately, I would think probably it's easier if you have them emailed to yourself. What you are going to get if you do this, you get the satisfaction of knowing you've seen many of the spring's best galaxies. I actually wrote that line by myself, and I'm really proud. That just sounds like, you know, really, oh, I'm so happy. Oh, it's so wonderful. Oh, hug me, you know. You will get an email certificate, okay? You will get your name in the reflector. You may or may not get your name in the AL's database. And I put it that way because the last two that they've done, that the big conjunction one, and there was another one, and I don't remember which, maybe it was a moon one. They haven't entered those things in the AL's database yet. So it's a case where, you know, maybe not on that last one, but certainly your name's going to be in the reflector and you're going to get a certificate that you can print. And the certificates, and this isn't the right one, but an Astronomical League certificate, whoops, come on, fingers. If you've never seen an Astronomical League certificate, they end up, I'm going to make a mess here. They end up looking like, is it on the screen? No. Well, anyway, it's a cert. Now I pick it up. Screw it. I give it up. It's a certificate. Now you got to do outreach, and that's part of all of these challenges. Okay. And so what could you do in terms of outreach that you would report? And I would say the easiest thing is to do some kind of EAA activity at a Friday night open house. You know, you set up your scope, you capture images, the visitors walk by and say, here, want to see a galaxy? Looky, you know, and you talk a little bit about the galaxy. You can talk about your equipment, how you did the image, in a sense, how long you've been interested in doing images. And I really do think that's probably going to be in the long term the easiest. Show up on a Friday night open house, you know, when the moon's not in the sky, and it'll be pretty easy to do. You could get together some friends, neighbors, family, that kind of stuff. Do it in your neighborhood, you know, if you know people and they're willing to show out. ASEM does stuff with the library telescopes. It might be a little harder to see the galaxies or image galaxies from a library location, but you know, it could work. And then I think there are things out there like the Night Sky Network, and I've got a hot link there. If you click on that, it would take you to Night Sky Network. You could sign up for that and try to do something there. The big time dates, this program actually started on March 1st. So we're already into the window where you can do the observing. Okay, everything's got to be done by the end of June 30th. And then all the things have to be turned in before the end of July. So July 31st, right, Mike? Mike says, right. There's a story behind that. Anything you've done prior dealing with galaxies, it's not going to count. But if you do image any of these galaxies, and let's say M81 would be part of the local galaxy group and cluster program, you could use that image as part of that program. To turn it in, you can either send it in by email or write a letter. Cliff Mygat is the guy who gets it. He's a real nice guy in Washington State. That's his email address. And I got to tell you, he's really good at answering email. So if you have any questions about the program, email Cliff. And I would imagine he'll probably get back to you within a couple of hours. Now, admittedly, he's in Washington State, okay? So if you do it pick some time, if you do it at 5 o'clock in the morning, it'll be a while before he gets to you. But yeah, he's usually good. And then ultimately, Cliff will do the certificates and he'll email them out. It'll only be after the end of July. He wants to do all of those things at one time. The AL does have a program. I don't know if this is going to work or not. Can you see that?
No, it's only showing the shared.
I thought it would be. So anyway, the AL does have a webpage, and it's that. And then Dan and I talked a little bit about it, setting this up for tonight. And he suggested he thought it might be a good idea for the digital SIG group, this group right here, particularly if you're a new imager. The idea of, hey, let's go take some of these 22 targets, not necessarily all of them, but let's try to capture some of them and let's try to show them at our next few meetings. In other words, let's show this at the April and the May and the June and maybe the July meeting, and just show 3 or 4 that each and everybody's done, and we can look and kind of compare and make some suggestions or anything like that. And so, does anybody like that idea? Is that an idea to go after some of these targets? And if you would like, I can put together an email and I can send out to the list what the targets are if you guys want to do that. For general ASEM kind of stuff, I kind of suggested that ASEM might want to do that as a groupish kind of activity. Go out to Bromelsic and use the scopes out there And the idea would be that one person would find the target, but everybody looks at the target, makes a sketch, or in that case, might take the view. And Cliff doesn't have any problem with piggybacking associated with that. And then ultimately, you know, you could do EAA, and we talked a little bit about EAA at this point 2 years ago when COVID started popping up. The idea being that we're going to use, instead of an eyepiece, we're going to put a telescope, we're going to put a camera on it, and we're going to capture that information. And it'd be relatively easy to do, I think, whereby, you know, you get the scope, you get the camera, you slew to the target, you center it up. The visitor actually takes the image, they press the button on the computer, and then ultimately we get them to share it. In other words, we get it emailed to them, okay? Ultimately, I think I know a way to get the email, though it's a little clunky. And so I'm still kind of trying to figure out another way of doing it. But I think that would be a really impressive thing. A visitor to Friday night open house would come out and you know, take a picture. And before they leave, they would literally have that picture on their cell phone. And so I think they would say, oh, these ASEM guys are really, really pretty cool. I think that's the last slide. See, I remembered. And I'm going to close that. And I've stopped sharing. Anybody got any questions? You want to know anything?
Yeah. I'll wait to the end.
And so Steve, I have a question. I looked over the sheet of you know, the instructions there online. Anyway, there's one thing in there that wasn't clear. They said they want you to supply an index number.
Oh, gotcha. On the PDF that lists their targets, you'll look and see it's numbered 1 through 22. I don't remember which the first one is. I know it's either M81 or M82 if you look at that list. And so the index number for the first one, M80, whichever, that's the index number.
Oh, like you mean on this? Well, that's not really clear.
So you're doing better holding up than I did.
It's not the NGC or IC number.
No, they ask for both the index number and the name. And the index number would be like 1 out of 22, which of the 22 it is. And then the name would be the NGC or the Messier or the Caldwell or something like that.
Okay, got it. Thanks.
So Steve, if we make a sketch, would we make a PDF of the sketch? And
if I were going to do the sketch, and I say this only because some of the observing programs I've done, you have to do a little sketching, and then I sooner or later need to do the sketching program that I'm working on. You would do it on a piece of paper, and then you could do it a couple of different ways from there. One way to do it is to use a cell phone and take a picture of your sketch, or if you got a scanner, scan a picture of your sketch, and then put it together in a document.
Okay, yeah, I could just anchor it on a field in a spreadsheet.
Yeah,
That way you can.
I would, rather than a spreadsheet, I would recommend doing it maybe like Word or something like that.
Okay.
In some kind of document, only because with the document, it's easier to adjust sizes and not have to worry about self sizes working out to have the picture.
One page per object. Yeah. Okay.
And then it may be easier for Grant's the sketcher. So maybe Grant could, if you have any sketching related questions, but it's also possible to get black paper and white pencils. And so particularly for galaxies, you might find that to be an easier kind of sketching kind of option.
Ah, okay.
What a lot of people do is they do the black on white sketch, scan it, and then invert it.
And the only problem with that is it's hard to guess what the contrast is going to be when you do the inversion.
Mm-hmm.
Well, with a tool like Photoshop, you can control that and get pretty close to what you remember. Because the problem with doing white on black is the white pencils don't really. That's a lot more difficult than you'd think to try to do white on black than black on white. That's actually a pain in the ass. Sorry.
Well, I'm glad we can use the C14 because I'll be just thrilled if I can see a few of them with my telescope. So that should work out. That should be fun. Now, this one, whatever I find here, that would also work for the Messier program as long as I didn't use a GoTo, right?
That is true.
Yeah, good point. So Steve, on your last bullet point about the visitors at the open houses snapping a couple of shots with the camera,
Mhm.
and then the issue is getting it to them.
Well, the truth is it can be emailed if they're willing to give us their email address.
Yeah, I was wondering if that might be the problem that you were talking about.
Yeah, no, well, that's only part of the problem. The problem is it's like, well, let's see, I got an imaging rig and I would rather use my ASI Air. And then how do I get the picture from the ASI Air to the laptop so then I could email it out? That's and I know a way of doing it. It's just,
And there is the novel solution that Dan and I kind of joke about. How would that person know the difference between an image that you quote captured with that scope and one of the stock images that you can just download online?
oh, they wouldn't, other than their memory. In other words, they would take it and they would see it on the computer screen, after it was taken. And then they would have to naturally assume that when it makes to their computer, their device, their cell phone, their whatever, that it's the same picture.
I mean, the fact that they push a button and then they wind up with an image. That's that joke that we have about, you get online to one of these remote scopes and and you take a shot, and how do you know the data that you're getting wasn't data that was captured n months ago?
Well, I can answer that one by saying, looking at the FITS header.
Digital data can be modified. Digital data can be modified.
So Grant, I was out at the park and Steve was helping me figure out some stuff about the ASI Air. We actually did this with a family group that walked by in the cold, and they looked over my shoulder. And I didn't do a great job that night of aligning and getting good long enough exposures on live stacking to produce a decent galaxy image. But it was close. It was a mediocre image. And I've done better ones. They were happy with that. But Steve's idea of throwing that image to someone's cell phone in real time, and part of the real time is you watch the image stack. You see it start out faint.
Now that's pretty cool. If it's being sent directly to their phone.
I think there might be a way to cast an image from my tablet to somebody's phone number, but I'm not sure. I'll practice. I'll play around with that and see if it's.
You can email it directly to their phone as a text, so it shows up like a text message or a SMS or whatever. All the common ones have some kind of phone number at something that works.
Yeah, in my case, Verizon, it's if you want to send a text via an email, it's the phone number v text. But if you want to send an image, it's the phone number v pic, PIC.
Oh.
If you try to send an image through the text channel, it rejects it. You get the text, but you don't get the attached image.
Mm-hmm.
But that's for Verizon. I don't know if other services have the same problem.
And I would also say another possibility is for me to run a web server on my laptop. I've installed Apache so many times I can do it in the dark.
I've found with a little bit of work I've done with the fainter, galaxies and stuff, you do have to kind of set up the exposure times and gain on my system appropriately so that it stacks up in a reasonable amount of time. You don't want to wait all night for this image to show up. You want something that goes from mediocre to a little bit better than that, in a minute or two. But it's doable. You just have to set up the right parameters.
And that's why I say like EAA kind of ways of doing it, because EAA kind of implies that you're using relatively short exposures, 30 seconds or less.
Yeah, 30 seconds is probably about the place to shoot for most of these, I think. They're all about the same magnitude, brightness overall, but I haven't looked at them all, so I don't know.
That's a good question, Steve. Setting up a what you call a server, a web server. I was thinking of Hotspot, and then you just type in you go to your browser and then type in an IP address, and
Well, I mean, already there are on a normal Friday night open house, there are at least 2 hotspots in the park. And it would be relatively easy to just, jump on with you could actually run it on the same Raspberry Pi because it doesn't take a lot of power to do. But it's like, if you got a laptop and you're connected to the Raspberry Pi hotspot that's in the 32-inch thing, you can look up your IP address and tell anybody to go to that IP address, and whatever's in that shared up directory, they can download on anything.
As opposed to having a web page at that IP address that shows the real-time stacking.
Yeah, that would not work so well. The real-time stacking has got to be probably on the computer that the camera is hooked to.
Okay. Yeah, it's an interesting thing.
So if we have nothing else, here's Joe.
All right, are you seeing my presentation, the title slide?
Oh, we see you now, so.
Me, okay.
But we don't see your screen.
All right. Let me see what I can do to fix that.
Share the screen, share the screen, share the screen.
Yeah, I'm trying to find a place on the Zoom to. Yeah, I lost my mouse here.
Might be the bottom of the screen where it says share screen.
He is.
How about that? Anything?
Nope.
No, not yet. Nope,
Yep.
there it is. We have your screen with your settings window on it.
Good. So that now has my title slide on it?
Yes.
Good. All right, I'll start. So I'm doing a presentation on coming up with a way of doing temperature compensated focusing on a imaging setup. And my motivation was the first year that I was doing astro imaging was the year before I ended up sending my telescope out to dark sky where Dan is located. And I was just kind of getting increasingly frustrated with the few number of good nights of imaging in St. Louis, and noticing how many times or how much time every night my telescope was spending focusing versus imaging. And so I was trying to look at how could I improve on that and spend more time imaging and less time focusing and still get good results. So I use Sequence Generator Pro to control my entire setup, and they've got a temperature compensating model built into it that if you can model your environment with the filters, then you can plug in the parameters of your model, and the software will manage your focuser a bit more discreetly between images, and depending on the temperature that you're measuring, will automatically modify the focus on a filter and keep things in focus over the course of the night. So I decided to investigate that, and I did this modeling process in like 3 years ago, and got really good results. Moved my telescope out to dark sky and tried it again. We had changed some equipment, mixed and matched some things, but I never could get the temperature compensating model to work again. With my new setup, with the plane wave out there and the plane wave focuser on the back, that I've gone through the same process, and I think I've gotten some pretty good results. So I was going to share my approach to that and kind of the results, and just kind of give you an update on how that's going. I'm using software, Sequence Generator Pro, and focusing using their 9-point focusing curve fit process, where you try to shape the V, or it's actually more like a parabola look. And normally that takes about 12 minutes to complete. That's the full 9 points, and that's downloading the files and doing the analysis and that sort of thing. And typically the way I've been, my legacy way of doing imaging, I might end up focusing maybe anywhere from 10 to 20 times a night, depending on how many times I change filters. So I'm just consuming a lot of my time just focusing. So I went through this process of that I had done 3 years ago to generate a temperature compensating focusing model, and I'm going to report on that. So let me go to the next slide here. Come on. There we go. So the goals for my process here were to model the focusing performance of the telescope for each filter over a wide range of temperatures to get a good leverage for building the model. Then use the best filter to focus the telescope for all the filters. And in that case, in explaining that, the luminance filter has the most light coming through it, and so it can get it can come to focus a little bit quicker than all the other filters, especially compared to like the narrow band, where I might have to expose for 10 seconds or more before I can get something that can be analyzed for focus. The luminance filter can happen a lot quicker. And if I can get a clear model of the filter constants, the constants on filtering associated with each filter, then luminance can be my reference focus. And when I go to switch to another filter, all I do is move the focuser to an increment of so many steps for the red filter, so many steps for the blue filter, and it'll be automatically in focus. And then the model that Sequence Generator Pro implements will also do micro adjustments on the focuser as temperature changes. So you don't have to every second or every degree of change or every 2 degrees of change do a new focus. It will actually micro adjust based on the model that parameters that you give it. So that was my goal, is to go through those 3 points and come up with a model. The assumptions going into this are that basically focus linearly will change with the temperature. There's not some unusual, nonlinear sort of effect going on. And that even though filters are advertised as parfocal, their actual focus differs slightly between the different filters by some constant amount. So you need to build this model for each filter individually. Just a summary of the results based on the legacy way of doing focusing. The model that I've come up with and implemented just this past month, I think I'm seeing nearly identical focus performance using the compensation model. I've reduced my nightly focus time by about 30% so far, and I think I can do even better, less time focusing with some additional adjustments to the model. I definitely think that I'm seeing a minimization of the impact of seeing problems with the images I'm getting. I'm still doing more analysis of that, but I think I'm seeing some improvements and avoiding some of the issues of seeing. And then because I'm changing the filters after every image, I'm starting to see sort of a smoothing effect of seeing across all the filters every night. So the legacy way of doing this was to capture like 10 images in a row in luminance, and then 9 images in a row in red, alignment in 9 in a row in green. And if I happen to have a great night of seeing, then those images look great and in focus. But if I had a bad night of seeing, all of the greens and all of the reds may be very poor. And with this approach, not having to refocus after every filter change, I'm able to spread good seeing or bad seeing across all of them individually, and no filter at the end of a full imaging session looks really bad or looks only really good. They're smoothed out, and I can kind of delete the bad ones uniformly across all the filters, and I can actually make more progress towards completing the target. In going through this, I kind of thought through what are the factors that actually can impact focus, and certainly temperature is one. As the telescope expands and contracts with temperature, and this model should help compensate for that. The filters themselves have different refractive characteristics, and so the luminance filter for the same temperature will focus at a slightly different focus point than the red filter, than the green filter, than the blue filter. But by building this model, you can characterize exactly how much of a difference those are, and then compensate that within the model. The focuser itself, if it's not performing well due to slippage or whatever, can affect focus. But you can control that with some maintenance. The mount performance, polar alignment, how it's tracking, periodic error can also affect your focus, but you can manage that by setting it up better, or getting your polar alignment improved. Air turbulence with seeing, cloud transparency, humidity, all those things can affect focus, and those are somewhat uncontrollable. So that's what you hope the model can help by shortening the amount of time that seeing can impact your focus process. Optical performance with temperature, the lenses can get distorted, mirror can be distorted possibly, so that can be either controlled or uncontrolled, whether you have a heater on those pieces. Wind can cause mechanical vibration, and certainly the mount can have mechanical vibration or flexure, which again, with more maintenance, you can control that. So those are all kind of the factors that I've thought about that you need to think through. Sequence Generator Pro, in implementing the model, once you create one, has 3 panels in their software where you can make these adjustments. And in the top panel, circled in blue, once you get the slope of the linear fit for your model, you can plug in the number, the slope of the number of steps that you have to adjust the focuser per degree of temperature change. You can plug it in there. In the lower left panel, you can see where in Sequence Generator Pro you set up the filters for the whole environment, and you list in luminance, red, green, etc., all the way through. In the column with the red and orange circle, you enter the number of seconds you want to expose the autofocuser images, so it can do the calculations on just regular autofocusing. And when you have a model and can understand what the focus point constants are for each filter, that column with the black circle, you can enter those constants in there. So that's how you manage the filter side of it. And then in the right-hand lower panel, and circle in green, is the place where you decide which filter will be your reference filter when you do all your focusing. And you can choose that there. And once you do and select that, every time you do a new focusing run, it'll pick the luminance filter to do that, and then make the adjustments based on the other column in circled in black and the other panel next to it to come up with the right focus for which filter you're going to actually use next. So that's kind of the way they're set up. However, the big point of this presentation is the fact that their methodology for finding the focus model is woefully inadequate. And I'm going to demonstrate that in a couple slides here. But I kind of developed my own methodology that I think has worked fairly well. This slide is an image of the data that I collected in modeling the luminance filter performance, and on the vertical axis you see focuser position graphed against the change in temperature over time, and all the white dots are all the data points that I collected over the course of about 2.5 to 3 months. And the blue line that runs through them is the linear regression curve fit that shows the focusing model for, or temperature compensation model for the luminance filter and my telescope setup. And I've got the calculation of the linear equation for that linear fit, where in green the focus position is the result of the filter constant plus the slope of that line times the temperature that you've measured, and that computes the focuser position, and the model then gives that to the focuser, and it moves to that point. And in theory, if your model's good, your image should be in focus at that point. So that's kind of the concept of it. What Sequence Generator Pro gives us guidelines for creating that model is over one night, collect these data points of focus position versus temperature over one night that has at least 5 degrees temperature change over the course of the night. And their suggestion is that sort of a model, when you do a linear fit, should be good enough to plug the numbers into their system. Well, I found that to be really bad, way off. And I'll show you kind of the example of that. This next screen shows what you can develop as far as a chart to generate the curve fit in either Excel, or I use the equivalent of Excel spreadsheet for Apple called Numbers. And when you do the linear fit, it'll actually compute the calculation that you see at the bottom. And in that orange circle is what they've generated for the linear fit of all those data points. And they also include an R-squared number, which is essentially how well that linear fit, or how well the data points fit to the model that the linear regression that blue line represents. And if R-squared equals 1, that means all of the data points lie on the linear regression line, the blue line. And I'm showing that in this example, my R-squared number is 0.78. And so that's a reasonably good fit, but not perfect. And that's why not all the points are laying there. But you get a sense of how good that linear fit is compared to the data points that you've got. And so the next 5 slides that I go through shows a series of nights as I progress collecting more data. And this is what I would have resulted with if I use Sequence Generators Pro recommendation of collecting data over one night where the temperature drops 5 degrees over the course of the night. And I get a line that is somewhat canted up a little bit more. At the bottom, you can actually see the numbers that were generated, the slope of the focuser steps that need to be changed per degree of temperature difference is 32 focuser steps, and the filter constant, meaning it's essentially the intercept of that line, where temperature is 0, the focuser should be set to 16842. And so that was what I came up with after one night. If I added a few more nights to it, the line starts to tilt down a little bit more. Add another few nights, the line tilts some more, another few nights, and suddenly this line keeps moving, and you can see now we're down to focuser steps per degree of temperature change of 13.1 steps, and the filter constant is diving down towards 16725, 16,725 steps. And finally, after about 40 sets of data points collected, I arrive at a roughly 4 focuser steps per degree of temperature change. And for the luminance filter, 16,731 focuser steps is the filter constant, that whenever I go to the filter luminance filter, plug that number in at temperatures when it's temperature 0, and that should be perfectly in focus. And you'll see the R-squared number has come up to around the number I showed you earlier, 1.79. What I'm looking for is for this to kind of converge, and as I add more and more data, these numbers don't change because the linear fit is starting to be stable. But I also basically want to see all of the other filters come up with the same curve fit, where in particular that the slope of that line, they're all starting to arrive at the same slope of roughly 14 focuser steps per degree center temperature change. And that was happening at around 35 to 40 measurements across all of the filters, but not quite. So here's the spreadsheet that shows on the left-hand side the columns of data that I've been collecting over the 2.5 months that I did this modeling. And the 7 filters, you can see blue, green, red, luminance, and then HA O3 and S2. And the data I collected across all those filters, and all the lines are getting close to lining up. But what I'm not showing here is that each filter had anywhere from 1 to 3 points that were quite far off from the line. And they really stuck out. I mean, you really looked at them and go, that doesn't look right. And there's a statistical analysis that you can do called outlier detection, where you look at the standard deviation of all of the points in reference to the model line, and which points lie over 2 or over 3 standard deviations away from the line, to show that that they're outliers, and you can discard them without impacting the model. And so I did that for all the filters, and at that point, when I removed all the outliers, all of the lines started to snap into convergence. So they all had very closely the same slope, which means that now your model is pretty close. If I go back, you'll notice on the luminance filter, there's one white dot that's the lower than any of them, and that looks in this view like it might be an outlier, but in fact that's within 2 standard deviations of the blue line there for the population of all the data points, and so that actually is not considered an outlier. All the ones I discarded on all the other graphs were farther away from the line than that by a considerable amount. Bottom line is, once I got to that point, all the models were starting to show reasonable performance. Does somebody have a question? I didn't.
Yeah, because this is still fresh right here at this point. So what you're basically seeing then is the temperature is not affecting the individual refractive indexes of the filters themselves?
That's correct. And in fact, I even contacted Bill Newbert to make sure that I was correct on that. Unless you're talking about really tremendously extreme temperatures, it's strictly the refractive property of the filter that impacts where it comes to focus. It's not the temperature. And that,
well, the temperature doesn't change. The temperature doesn't change that.
Correct.
Thank you.
And it's constant. So that's that intercept that I was talking about earlier. At 0 degrees, this equation essentially gives you the focus point. I'll go back to it. That white number, 16,731. That's the focuser, where the focuser should be pointed to or set to when the temperature is 0. That's proven out in the linear model to be the filter constant for the Lume filter. And each of the filters has a slightly different number for their constant.
Okay, one quick question. Are these filters all from the same manufacturer or
yes,
different? Okay, so
they're all Astrodon, and they're all advertised as being parfocal.
Okay,
meaning they should be perfectly in focus.
So you might expect maybe some differences if you mix in a ZWO filter in that.
Yes. And in fact, the first time I did this, before I left St. Louis and took my telescope out to dark sky, I did have a mixture of ZWO at that time when I started this process, and they were quite different.
Okay.
Cool. Yeah. So I'll just make that reference. The first time I did this, it was successful on my refractor here in St. Louis, and I was really seeing I was just really pleased. The noticeable improvement in performance of the imaging process. Moved that refractor out to dark sky, and Ryan Jones and I had swapped some equipment, kind of sharing some equipment, building up that telescope, and I couldn't get the same results when I went to this modeling process. In fact, it was so bad that all of the color filters had their lines tilted in one direction, and the luminance filter was in the opposite direction and not very close. And the scatter was very, very wide. When I kind of looked at this online, I saw a lot of reports in cloudy nights of other people having the same results. And my best analysis of that, or my best guess, is that it's possible. So the temperature that's being used in this calculation, or being reported, in Sequence Generator Pro is the temperature that's being measured by the focuser. And in that case, I was using a moonlight focuser. Worked great in St. Louis, not so great in dark sky. And I can only think that possibly somehow the way the temperature probe was plugged in was a little loose, or because we have more humidity in St. Louis, the contacts were better, but in dry environment, it wasn't as good. And maybe I just wasn't getting as good of a measurement. Dan and I actually kind of conversed back and forth. I think there are certain kinds of telescope models that just don't conform to this kind of analysis. They don't have a linear change associated with temperature. Bill also mentioned to me that certain refractor designs, the metal can actually kind of, I guess, twist the objective, or the glass itself can have sort of a nonlinear response to temperature change. And in that case, this kind of approach just won't work. But in my case with the CDK, it's mirrors and carbon and aluminum frame, and they have apparently a very stable response to temperature, predictable response, and so I was able to get numbers that work pretty good. So getting the data into the spreadsheet, for me, I came up with my own little trick to doing that. And what you're seeing now is on the left-hand side is a screenshot of the file directory for the images that I took when I was targeting or imaging the target ARP78. And I'll show you that in a minute, the results. And each line is 1 8-minute exposure. And the green line separates 1 night's worth of data collected, and below the green line is another night for three nights later of another set of data that I collected. The panel on the right-hand side is a snippet of the spreadsheet that I was copying the data into. And in the left-hand column on that side, you can see the filter designated which one I'm collecting, the temperature for that particular image capture, the focus point that was captured, that arrived at in the focus process, and the date of that. That's ARP78. It's a galaxy out there, kind of interestingly twisted. And here's that same data for that image, showing how I use the Sequence Generator Pro's file naming convention to capture the important data elements. So in the far left column, you can see the filter name for each image. The middle column is the temperature, ambient temperature that was measured by the focuser at the point when the imaging took for that particular file, and then the focuser position during that image. And then the gold highlights are all luminance filters, and then you've got the blue highlights for the blue filters, red for red, green for green. So that's kind of what every morning I would get up and look at the data from the previous night for that target, and I'd look through and see the places where the focuser position column didn't change for, in this case, maybe 8 or 9 images, which meant that the very first one was the one where I focused, and all the other ones where I just went through and continued to hold that same focus point and captured the next image. But you can see under the ambient temperature column, you can see the temperature slowly dropping as it cooled off over the course of the night. As by way of example, in that second day, but just right below the green line, I get 2 images that I captured, and then the temperature's dropping so fast across those essentially 16 minutes of image capture that it's gone more than 1 degree of change. And I've got Sequence Generator Pro to go back and refocus after every degree of change, and another set of images are captured under a new focus point. But you can see now, instead of in 2 images having a degree loss, I'm going through, what is that, like 8 images before a degree of temperature change. And then at the green filter, a changing filter, it refocuses and starts again. So every morning I wake up, I look for those differences, and I'm circling the data that I want to capture, because those are the data points that are captured right after the last focus. And I transfer them over to the spreadsheet the next day or that morning. I then go through and sort the data columns so that all the blues are together, all the greens are together, etc. And let me see if I can, what the next slide is. And then I generate a graph like this for each of the filters, and throw the linear curve regression into the mix, and I can see where I'm at on each one. So I went through that for 2.5 months, and eventually came up with a set of graphs that you've already seen. But basically, these are the final graphs showing the curve fit for all the data collected for all 7 filters over the course of those 2 months. As I mentioned, I went through and removed the outliers that had greater than 2 standard deviations from the actual curve fit line. I then chose my parameter models, model parameters, and loaded those parameters into Sequence Generator Pro. That other table there is showing my final results after going through that. So for the luminance filter, you can see the slope of the line was 13.8, for red filter was 14.1, et cetera, going down. The average shows at the bottom, the average of all of those filters, that slope of the line ended up at -14. And so I chose that, selected that as my model parameter for the slope of the line, plugged that into Sequence Generator Pro. And then in the third column there under intercept, I use those exact intercept numbers for the focuser position at temperature 0 degrees for each of the filters. I plugged that into Sequence Generator Pro, and then chose the luminance filter as my, always use this filter for all focusing going forward. Just to compare the results between the linear fit for all the filters, R squares, you can see, end up all averaging about 0.79, which are pretty consistent across all of them. A standard deviation of how all of the points fit against all of their individual lines ended up always being pretty close together. You can see the narrowband filters were the O3 and S2 were a little bit farther off, which probably means it wouldn't hurt to gather more data in the future for those two to kind of get their standard deviation to be about equal. And then I looked at the slope of each individual filter against the average that I used at the bottom, -14, and saw that the slope from each line, from each filter compared to the average of all of them ended up being really rather small. Essentially, those fractions, the 0.272 for the luminance slope average difference on that far right column, means it's just a 0.3 of a focuser step on the plane wave focuser difference between what the filter said and the average I'm using for the whole model. So that's really, I think, as good as it's going to get for those. So what are the results? In general, I would say that that I'm getting equivalent quality out of my focusing operation with the temperature compensating focus model. Although I kind of qualify that, and I'll explain that a little bit in a couple slides from here. I'm definitely getting a much more uniform focus quality across all the filters. So when I'm done imaging the next target, M82 or something like that, I'm finding that the focus quality measurement for red, green, and blue is almost identical across all the filters. Where before, with my legacy way of doing it, one night of bad seeing could dramatically impact the red filter, and I get done with the targeting in my imaging the entire M81, and suddenly the red filter shows up as being a lot worse in jet compared to the red, green, blue, or excuse me, the blue and green. And therefore, am I going to get some anomaly when I stack those together? With this model, I'm seeing much more uniform across all quality, across all the filters. I'm doing probably at least 5 fewer focusers per night. And I'm probably going to reduce that by implementing the model a little bit more in the Sequence Generator Pro software. And that's giving me right now at least another hour of imaging every night. So I'm getting a little bit more done with that. What I've added here is a table of how I grade the performance of focusing, or the image quality for every image. And I'm using Sequence Generator Pro's image grading tool, and basically it runs. You give it all of the image files for M81, and it goes through and computes the half flux radius for each image, the average radius for each image for all the stars on each image, and shows that in a graph, in a table, and then it shows the average half flux radius for each filter in that total data capture. And for creating the model, I imaged 16 targets total to come up with the model, and the first row of data on this table that you're seeing on this chart shows the average performance of all 16 targets that I imaged over those 2.5 months. So, for instance, the average luminance half flux radius measurement for all the targets ended up at 5.28 pixels. For red, it ended up at 5.231, so on and so forth across the board. And then I've captured 17 targets using the compensating model, the temperature compensating model, and the results are slightly worse. So, for instance, luminance, I'm getting 5.86 half flux radius pixels per the average grade. The red was 5.65, and so on and so forth. But I'll also say, sort of qualify that by saying, I noticed that the general seeing conditions at dark sky for the October, November, December timeframe into January, I thought that they were generally better than for the February, March timeframe where I've been using the focusing model. So it's not hard for me to explain why the average luminance grade for half flux radiance is slightly worse than it was during the model creation time. What I can say is that if I look at that, I can say, well, maybe that's sort of a measure of how bad the seeing was after I implemented the model. And when I divide that HFR number for luminance during December, January timeframe into the next one for the modeled data, it's about 10% worse. If I use that as sort of a normalizing factor, and let me get this up here. There we go. And adjust all of the compensation model parameters, or the grades, so that essentially the two luminances are equivalent by the factor of badness of seeing over that time period, then it's suggesting that the red, green, and blue filters actually came out even better than when I was developing the model. I'm a little bit leery of putting too much faith in that. I'd like to use this longer to see if under good seeing conditions, I see comparably better results, but I am heartened by the fact that these numbers are, if I normalize the performance against bad seeing, it looks like the performance was actually a little bit better. I'm not sure if I was clear in describing that, but I'm just trying to, kind of analyze this a little bit better. I think you definitely can see, like if you look at the middle data line there, compensated focusing, you'll notice that HFR numbers for red, green, and blue are relatively close to each other compared to the spread of numbers while it was developing the model in January and December, November, where the performance grades are worse by a little bit. So that I feel like that's possibly showing the model working a little bit better. And then my final slide here, when I look at how badly the grading, the performance of luminance decreased with the compensating model by 10%. The degradation on the other three filters, red, green, blue, was actually only 6%, 3% or 1% difference. So that could also be another factor just indicating, showing that the model is working. And I was just a victim of poor seeing during this tryout period of the model. So anyway, I hope I explained that clearly. I know I kind of got a little bit confused in this last section here, but that's kind of where I'm at. I'm fairly pleased with the results. I have not been able to actually complete the processing of all the images from this time period, and I hope to do that in the coming weeks here. But I will say that I haven't done any A/B testing of the legacy versus focusing versus the compensating temperature compensated focusing, just to see. But I did do some comparisons of not removing poor images from the stack set versus removing all the bad images. And when I compared the results of those two stacked calibrated images, they were completely identical. I couldn't tell which was which. So I'm not sure that the differences I'm seeing in this table are that relevant, but that's where I'm at this point. Dan, I don't know if you can add anything to that as far as your experiences with how you grade and the impact of seeing, whether you know how much you notice that in the stacking process, whether it's somewhat cured in the stacking process or it really carries through. But that's where I'm at with this right now. Do you have any thoughts?
Yeah, for me, I tend to find if you take enough exposures, it tends to not make sense for me to throw away stuff unless it's really bad, and really bad meaning it's trailed or something. But I will throw away, really bad seeing stuff. And this time of year, the seeing is not good in New Mexico for us because of it's windy.
Yeah.
And yeah, I've tried different things and they both come about the same. It just assuming that you have a lot more of the good ones than bad ones.
Yeah. Well, in the end, I'm definitely getting more hours for more time per night imaging and less time focusing. And that's one of the goals I was going for with this. And I don't think I'm seeing a significant degradation in performance in that. So I'm pleased with that so far.
I mean,
any questions or?
An hour extra a night.
Yeah.
Pretty phenomenal.
Yeah.
So, and are you seeing what you think are improved images, or is it just you're spending less time tweaking and more time imaging?
Yeah, so definitely that's without a doubt one major benefit to doing this is more time imaging, less time focusing. I would definitely say that it's been a definite improvement to be able to switch to the filters after every image to essentially smooth out good seeing or bad seeing across all the filters. So I don't end up with the red filter at the end of a stack being slightly fuzzier than, or noticeably fuzzier than the green and red, green and blue. And that's now definitely smoothed out, and it's more even, and I spend less time trying to go back and fix the problems with one filter. That's for sure an improvement. I need to do more final processing of the images to actually look at it and say, can I tell a difference optically or visually? But I definitely haven't seen any degradation in performance visually at this point the numbers show a slight difference.
Now to unveil a part of my good ignorance, I thought these software packages had autofocus capabilities where you use that FW value to, and so you were kind of like, hands off on the focusing.
Well, they have their own auto focusing process, and they can get to focus, but every time you change the filter, you definitely have to do a refocus because of these constants are not the same between the filters. So without a doubt, you have to refocus every time you change filters.
Right.
Unless you model it like this.
But I thought the software was doing the autofocus when you change immediately. But
it will, but I'm spending an hour more doing that without this model.
oh, I see. Oh, I got you. Okay.
Yeah.
All right.
So Joe, I had a comment. First of all, you did a lot of really good disciplined data collection here and organized it really well. So, and then going back to those graphs you had, I was really impressed that the residual plots on those are going to be really smooth and even across the whole range of temperatures. You don't have any systematic errors or variations going on at one end of temperature versus the other in your drivetrain or anything else. And that's kind of an important thing, sort of helps validate the model, I guess. But the other thing that occurred to me is you made no mention at all of focus or backlash. Like, I guess that's either taken care of somehow or doesn't exist in your system.
Well, that's definitely a problem, and without a doubt, that would potentially hurt the linearity aspect of this, or create a lot more outliers where you just have to collect a lot more data to be able to get that linear fit. But I'm using the plane wave focuser, their top model, and it is rock solid. I'm seeing no evidence of backlash in my images. So I think it's just the plane wave does a really good job of doing that. The Moonlight focuser was also pretty good, I think, as well. Dan, I don't know whether you see any backlash in your Moonlight focusers, but I'm pretty impressed with that. I've heard of others that are not as good, but I think it's just the quality of manufacturing and design, I think.
Yeah, the Moonlights are really good, especially the higher end ones. I haven't touched the one I haven't touched it since I installed it. The add-on motors, the EAF has some issues. It loosens up the ASI model, and that would cause some issues. But I don't know how you program that in, if there's ways of overcoming that or not.
I think some of the software will allow you to do some sort of like quantifying the backlash, and then it will, if it's going to reverse directions, it'll try to take that backlash out before it starts to actually set the distance. But I don't have any experience with those.
Yeah, that's what we do with regular visual telescopes. Is you always rack it. If you have to go, you rack it in, and you always approach your focus from the same direction.
Yeah.
So you always go past a point when you're changing direction, so that you can. For me, I always like to rack out for the final focus, so I'll rack all the way in past the focus and then come back out. So I would have thought the astrophotography would be the same thing.
Okay.
Yeah, now that you have the data, and I'm assuming you're still probably collecting more, can't you take it to the next step once you're happy with that and just turn it on so that it auto moves as the temperature changes?
I've actually just implemented that. I was reluctant to make too many changes simultaneously, and so like the last week or so, I've turned on that auto increment the focuser with temperature change, and so I'm going to see what those results look like going forward. But the grading process, I'm not seeing anything get worse for sure with that added in. I still force a refocusing every degree of change. I think I will start to loosen that, and maybe every 2 degrees or every 5 degrees, something like that. I may, in theory, if this was all perfect, in essence, you could essentially focus at the beginning of the night and not focus again the rest of the night. I'm not sure it's that good, but I think I can start to loosen this a little bit more and get even more imaging time and less focusing time.
Yeah.
So Joe,
Yes.
are you finding yourself using that extra hour to get more subs or more objects?
I would say both, but because I usually try to, well, especially being in a higher wall observatory, I can't go too low on either side. So I'm usually just trying to capture within about 20 degrees of the meridian, maybe 30 degrees of the meridian. So I'm switching back and forth between images over the course of the night. And so I do run through maybe 3 or 4 images a night in doing that. And then it's maybe a week's worth of that imaging over those, all of them before I finally complete it. But if I get one particular, very high object that I can pick up early in the evening and track it all the way towards the end of the evening, several hours, I'll do that occasionally. So it's a little bit of both.
Wow, if you have that limitation in movement, that extra hour, you're right.
Yeah. Even more valuable when you're in St. Louis and don't have hardly any more, time to spare just because of cloud cover so often. That's what motivated me to look at this the first time, was when I still had the telescope in St. Louis.
So I'm kind of chuckling because we are so seeing and light pollution limited here.
Yeah.
Like, is this like a 5th order solution where 3rd order solutions don't really get you much? But is this really helping in a situation like St. Louis? I mean, does this help us eke out just a good portion more?
I would say there is a potential that it is, because I'm always using the best filter to focus with. And if my models are good, then I can make incremental changes or constant changes to get to, the right focus point for each individual filter. And so if I'm spending less time exposing, seeing is moving the star around less than if I spent 10 seconds or 20 seconds for some of the narrowband filters to get that focus point. So I would say there's the potential that it's helping beat seeing just a little bit.
Okay. Yeah, I'm trying to think about that. And Dan and you guys that focus from within the confines of this light polluted sky in Missouri, does the temperature change faster than the weather induced seeing? We'll have a weather induced seeing where it'll be clear, and then you have all of a sudden you have this jitter caused by some jet stream parcel of air that goes by. And the question is, are we being more affected by the atmospheric seeing or the temperature induced seeing problems?
In St. Louis, I would definitely say the atmospherics.
Yeah, the thing, the atmospheric stuff really wouldn't impact the focusing. Your end result would just be worse, but the focusing is still the same here, whether the skies are good or bad. But the temperature definitely impacts it more, would definitely impact it because everything's moving in different directions.
I would add a caveat there. I think that especially with bad seeing, I noticed that focus performance is just generally worse. And I'm attributing that to just the wobbliness of the star during the 10-second exposure is slightly worse focus than if it's really clear. I mean, I would agree generally with your statement, but I think there is a margin of degradation because of that, especially for the longer, the narrowband filters, trying to focus them.
Yeah, I guess where I was kind of going there is when you go out to dark skies, steady skies like New Mexico, this is a real benefit as opposed to the ever-changing skies here in St. Louis. And I guess that's where I was kind of wondering.
Yeah, I would say that. I would also say that before I moved everything out there, I was surprised at how much this improved my focusing in St. Louis before I left.
Okay.
But I don't have much more experience with that because most of this has happened out there now.
Cool, man. Like Dave said, lots of good work there.
Thanks.
Thanks, Joe.
All right.
Hey, Joe, can I ask a couple
Yeah.
questions
Yeah.
from someone who's never done any? Like I use a DSLR, so I don't do the filter stuff right now. But you were saying that you focus on the best filter. What makes the best filter? Did you determine that, or is that something that?
It's so the Sequence Generator Pro makes that recommendation, and I call it the best from the standpoint that I can usually get a pretty good focus on a star within about 2 or 3 seconds of exposure. With the broadband, it's more like 4 to 5 seconds that I need to expose on those filters to get them to focus consistently. For my narrowband filters, I'm having to expose the images for the focus purposes at least 10 seconds. And even then I'm seeing a lot of failures. So that's my criteria, is that I don't have to spend as much time exposing to try to get, the image and then analyze it and say, is it in focus or out? And so therefore I'm not getting as much variation showing up on the exposure to do the focusing. That's my criteria for saying it.
So you're doing the focus on like the luminance, and then you rotate the blue filter in at the same focus. Is that
right? But the model then says there's a slight difference in this constant. And so when I switch to the blue filter, the focuser also moves a small few steps to come to the right focus for the blue filter based on that constant. The difference in the two constants between the two filters.
That's cool. Thank you very much. And then the other question I had was one of like the statistics on your regressions. I don't know if you've looked at this, but you kind of just led me into it there with what you were saying, because you saw the different intercepts. Have you looked at like the standard deviations of those intercepts to see if they actually overlap with each other, and that's how they're saying they're parfocal, or are they actually like different within, like outside of uncertainty?
No, I haven't done any analysis on that, and probably to do that, I think you could create an experiment to do that, where at the same temperature, at one same temperature, you always take a whole series of measurements and see if you come up with the same focus point for each filter. I would say, this is anecdotally, that with the current setup, and I think this goes to the quality of what PlaneWave has done with their focuser, that I see pretty much the same focus point come up every single time. If I do like 3 focuses in a row, I'll end up with the same number, which gives me some confidence that everything's working and the filter constant number I've come up with is probably pretty accurate. I don't know how relevant the differences is in the constants. In other words, if I just pick the luminance constant and always use that and never adjust it for each filter, but just let it go, I don't know if that would, you could actually detect the difference, but they're not actually parfocal, is what the numbers are saying.
Yeah, what Michael said, you can actually run a hypothesis test to see if your slopes or your intercepts are different. And it may be that for the number of measurements that you have, the results don't indicate that you can say that they're different. It's just something else you could do that it might help simplify your model and maybe simplify how you're using things. But it's something to look at in the future. I mean, right now you're fine. It's great. It's really fascinating. You went through so much effort to make such great data collection, but you can do that. You can compare the slopes and the intercepts.
Those I haven't done it in numbers, but like when you look at those kind of regressions in Excel, they'll output like, you know, the intercept and the R squared, but all the variance data for all the different components is in there if you ask like Excel to tell you those things, and then you can look at the, you know, the 1 sigma uncertainties on those intercepts and just see. Basically, it's like a way to look at your noise, essentially, right?
Yeah.
That's
I'd love to be able to do that. That's a level of statistics that's beyond my capability. I've sat next to some really good statisticians, but I'm not a statistician. So,
I think as far as you've gone, you're very close. You could do that.
Publish those numbers, Joe, and I'll bet somebody will take a look at it.
all right, I can put it out there someplace.
Yeah, it's been a long time since I worked on mine, but I found that on my setups, when I figured out like the critical focus zone,
Yeah.
and with my particular focuser, my focuser has 100,000 something steps on it. They're very, very small. And so even yours looked very close. And I have a feeling your focuser's got a lot of steps in it. I think if you could find those numbers, I have a feeling you're going to find that the difference in focus points is extremely small and probably smaller than being perceptible, for lack of a better term.
Yeah.
And you might find that because once I found that out, they were so far away from being different, even with my botters, that I just focus with the luminance and that's all I do now.
Okay.
But that would be definitely worth looking at, because like I said, mine, some of them are 100 steps from each other, but in the critical focus zone, I think I have like 500 steps across it, and there's little or no difference as long as it's within that zone. So it didn't make sense for me to focus with the other filters when I tested it.
Yeah.
But
And I totally get that. It's sort of like a sensitivity measurement or something that, and I've thought about doing that at some point. I was really impressed by the one situation where I described. I ruthlessly rejected the bad images for this one target, and I did another stack of putting them all in there. And when I did an A/B comparison, I couldn't tell the difference between them. So I won't be surprised if I come up with the exact same conclusion you just described. That this is I'm counting angels dancing on the head of a pin, sort of thing.
Yeah.
yeah, and Michael, one other thing, I believe Joe is doing full frame focusing.
Yeah.
That I do single star focusing, the older style, and so my focus runs are much quicker than his. I actually slew to a certain magnitude star, focus and slew back. That takes me a minute to a minute and a half to do. So there's different ways, and you can still do the temperature compensated focusing that route too. It just depends on what software you use. It looks like everyone's going to the full frame, but single star does work well.
Mm-hmm.
Yeah, I couldn't see a way of doing that style of focusing in Sequence Generator Pro, so I didn't pursue that.
Yeah.
Well, great presentation. Thanks a lot, Joe.
Thank
was
you.
A lot of effort.
Thanks.
Too bad Will didn't stick around.